All right, we are starting 1-5. We're going to very quickly do this warm-up. All this is asking is if sine and cosine are positive and negative in each quadrant specifically. So quadrant 1, remember, it's cosine, sine. So cosine goes with x and sine goes with y. That's the important part, to go with our x and y axis, okay? So quadrant 1, sine is up, so that's positive. Cosine is right, that is also positive. Everything is positive in quadrant 1. Quadrant 2, sine is y, that is still up, that's positive. Cosine is to the left because it's x, left is negative, so in quadrant 2, cosine is negative. Quadrant 3, we are down and left, so both sine and cosine are negative. In quadrant 4, we are right and down. Okay, so cosine is to the right, that's what's positive here. Sine is down, that's negative. Okay, hopefully that stuff becomes really easy to remember. You just have to know that it goes with x and what goes with y. We are going to work through the Pythagorean identity today. Similar to your Pythagorean theorem, based on your Pythagorean theorem. This is going to come back again in a later section, so we're going to see this a couple times this year. If you remember, your Pythagorean theorem says that legs squared plus the legs squared in a right triangle is equal to your hypotenuse squared. Well, generally, we just say a squared plus b squared equals c squared, right? If I would have asked you, that's what you probably would have told me. But it should just remind you that a and b are the legs of your right triangle, and c is your hypotenuse of your right triangle. So leg squared plus leg squared equals hypotenuse squared. If we go into a unit circle and we draw an angle in standard position, that's the red. Okay, this is what we've been doing for over a week. So the red is my angle. The point out here is my cosine and my sine, correct? It's my x and my y. That's what we just learned yesterday. All of those things are things that we know. The only thing that we're adding is the yellow dotted lines. Those yellow dotted lines make a right triangle out of my angle that I already had drawn. Okay? So if I'm just looking for fun, just to see this right triangle, this is a leg, and this is your hypotenuse. So let's talk about this a little bit. This bottom leg is how far to the right you are moving to get to that point up here. Well, the right movement is the x coordinate of the point. So if this were, just pretend, if this was 5, then the x coordinate of this point would be 5, because you'd move right 5 to get to that point up there, okay? So that's the x coordinate of the point no matter how long it is. On the contrary, this vertical leg is the y value of that point, because it's how far you're moving up and down to get to that point. So each of those legs, one of them is the x value, one of them is the y value. Remember that x and y are sine and cosine, or cosine and sine. So this leg is actually the cosine. And the vertical leg, these bells, the vertical leg is actually the sine. Okay? So cosine, sine. The hypotenuse is a whole other story. What in the world is this? Well, let's zoom out for a second and look at it. If I look at the picture as a whole, the hypotenuse is a radius of my circle. It's going from the center to the outside. That's a radius. Well, what do I know about the radius of my circle always? The radius of my circle is 1. So my hypotenuse is 1 automatically, which is good. Makes things a lot easier. Okay? So, back to my Pythagorean theorem. This is like a proof. I'm proving to you why this is working. My Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So let's stop generalizing it and write down what I actually know about a triangle in my unit circle. I know that one of my legs is my cosine, so cosine squared. I know that my other leg is my sine, sine squared. And I know that since it's a unit circle and my hypotenuse is the radius, then my hypotenuse is automatically 1. Technically, sine and cosine are always of an angle, so whenever you write sine or you write cosine, you should put theta at the end if you don't know the angle. So it is a version of my Pythagorean theorem. It's just translated in to fit our unit circle. Okay, so this is everything that we already said. This is everything I wrote up there. So you need to write things down, you can. But this is your Pythagorean identity. Cosine squared plus sine squared equals 1 squared. Well, what's 1 squared? 1. So, cosine squared theta plus sine squared theta equals 1. That's your formula. From here, it is simply algebra. Okay, so I'm not going to hold your hand and baby you through solving like we're freshmen. We're not doing that. So you're going to have to keep up or pause it and figure out what we're doing. Our steps. You are plugging in what you know. So you are either going to know sine or you are going to know cosine. I'll give you one of the two. Okay? Then you're squaring whatever needs to be squared because it's not just sine plus cosine, it's sine squared plus cosine squared. So you have to square the things that you know. Isolate your variable just like you would do any other time. And then you have to decide whether your missing piece is positive or negative. This, step 4, is the part that everybody forgets. And you can't forget it because it depends on what quadrant you are in. That will be given to you. But then you have to decide whether it's positive or negative, which is using what we just did a couple days ago. All right. Formula is cosine squared plus sine squared equals 1. Question number 1 says find the cosine if sine is 3/5 and is in quadrant 2. This quadrant piece we will deal with at the very end. That will be the last thing we do. We're going to right now just focus on the sine and the cosine. So cosine theta, I do not know it. That's what we're looking for. So you just write cosine squared theta plus. I know sine is 3/5, so I'm plugging in 3/5. But remember, it's not just sine, it's sine squared. So you have to put the little square at the top. Equals 1. All I did was plug in sine where sine was. That's it. Everything else stayed the same. Step 2 is to square the parts that need to be squared. Well, cosine squared, I can't do anything with that right now because that's what I'm looking for. 3/5 squared, if you want to do it in your calculator, you put in parentheses 3/5, close parentheses squared. The easiest way to do it is just to square the top and to square the bottom. 3 squared is 9. 5 squared is 25 equals 1. We are solving for cosine. That's the goal. At the end of this, we need cosine by itself. So in order to get cosine by itself, we have to subtract 9/25 from both sides. So it's gone on the left. We are left with cosine squared theta on the right or on the left. And 1 minus 9/25 is 16/25. You can do it in your calculator, or you can know 25 minus 9 is 16, because 1 is 25/25. because you have to have a common denominator to subtract fractions, okay? 16/25. We are looking for cosine. Right now we have cosine squared, so we're not quite done. What is the square root? Boop, boop. That's how you get the cosine by itself, okay? Because if cosine is being squared, the opposite of squaring it is to take the square root. So the square root of cosine squared is cosine. That's the goal. We have to find the cosine. 16/25. Luckily, both the top and the bottom are perfect squares, so you just take them out. So the square root of 16 is 4. The square root of 25 is 5. I guarantee last year Miss Blasey banged it into your heads that if you take the square root of something, you need a plus and a minus. There are 2 answers to square roots. So right now my answer is that cosine theta equals plus and minus 4/5, positive and negative 4/5. Almost there. This is where the quadrant part comes in. We don't need both answers because it told me that I am in quadrant 2. So cosine in quadrant 2. Think about it. Cosine is your x. In quadrant 2, is your x positive or negative? In quadrant 2, x is negative, so we want the negative answer. So my answer is cosine equals negative 4/5. Okay? It's just solving. It's just algebra until the very last step, which is what we did yesterday, knowing where things are positive and negative. Okay, we'll do one more. Find sine if cosine is negative 1/4 and is in quadrant 3. So cosine is what they give me this time. So negative 1/4 squared plus, I don't know, sine squared equals 1, always. So this time they told me cosine, so I plugged it in for cosine. I don't know sine, don't forget your little squareds. Anytime you square something, it comes out positive. If you square the top and square the bottom, negative 1 times negative 1 is 1. And then 4 squared is 16, so it's a positive 1/16. Plus sine squared theta equals 1. All right, we need to get the sine by itself, so the first step will be to subtract 1/16 from both sides. Sine squared theta equals 1 minus 1/16. If you want to get the common denominator, 16/16 minus 1/16. 16 minus 1 is 15. So 15/16. Or do it in any calculator. 1 minus 1/16. All right, we are not done because currently that says sine squared. I don't want sine squared, I want just normal old sine. So in order to get the sine by itself, I have to take the square root. So it drops out. Over here, you're taking the square root of something, so you have to have a plus and a minus. 15 is not a perfect square, nor is it divisible by any perfect squares. So it stays in the root, square root of 15. 16, on the other hand, is a perfect square, so you get to take it out. So the square root of 16 is 4. All right, last part is whether we want the positive answer or the negative answer. So we need to look at the quadrant. We are in quadrant 3, and we are solving for sine. Sine is y, and in quadrant 3, y is down, so it is negative. So we want the negative answer. So sine theta, final answer, negative square root of 15/4. That's it. Okay? All right. 1-5 worksheet. Let me know what your questions are.